Alright guys, so it looks like we're going to be virtual again today, so that's unfortunate, but it is what it is, so I can't change that. So what we're going to do is we're going to continue on with the videos, learning through the videos. So what we're starting in Chapter 2 is reasoning and proof. Now hopefully you kind of got an understanding of those from the vocab sheets that y'all went over yesterday, that you filled in. Hopefully you did. If you did not, you need to get them turned in, otherwise you will not get credit. I gave you credit for Chapter 1, but I will not give you credit for Chapter 2 unless you get it turned in. Now, with reasoning and proofs, our first kind of main thing we're going to look at with this here is conditional statements. Now, a conditional statement is a logical statement that has two parts, a hypothesis and a conclusion. When a conclusion statement is written in if-then form, the if part contains the hypothesis and the then part contains the conclusion. So if, in other words, we say it as kind of if P, then Q. If the hypothesis, then the conclusion. If P, then Q is how we write these out. Or kind of P implies Q is what this symbol's over here mean. P implies Q. So if we look at this here, so our first one, all birds have feathers. So we want to write it in if-then form, and we can use the red to identify the hypothesis and blue to identify the conclusion. So you will have to be doing some identifying hypothesis and conclusion on the homework. So our hypothesis, what is it? We're talking about all birds, if it's a bird. So let's use the correct color. So red for the hypothesis. We're talking about, the hypothesis is talking about birds. In blue, if it is a bird, then it what? It has feathers. So our kind of overall statement for if then is if it is a bird, then it has feathers. If it is a bird, then it has feathers. So we don't have to have the correct exact order. I'm not taking word for word, if all birds then have feathers, because that doesn't quite make sense, but we could use that. If all birds then have feathers. Well, it's not actually, I take that back. We can't really use it because it's way too chunky. It doesn't work right. It doesn't flow. If it is a bird, then it has feathers. And we need this if then. And sometimes we do have to rewrite it. Sometimes we won't. But in this case we do, because we need the hypothesis. It is a bird. Then it has feathers. And that's it. Our hypothesis was if it is a bird. We're talking about birds. Then it has feathers. So here, this one's a little bit more easier than the last one because it's worded a little bit better. You are in Texas if you are in Houston. So if kind of signals the hypothesis. If you're in Houston, then what? You are in Texas. So really this one here, we just have to reword it a little bit. If you are in Houston, then what? If you're in Houston, then you are in Texas. So this one here was worded a little bit better than the first one, just in that we were able to just straightforwardly translate it from one to the other. Because you're in Houston is the hypothesis, you're in Texas is the conclusion. And that's all we have for this here. All angles are acute angles. So if what? If it's a 30-degree angle, then what? Then it is an acute angle. If it is a 30-degree angle, then it is acute. And that works. And we really want to try to make a true statement. We'll talk about true and false here in a little bit. But it's a true statement because if it is a 30-degree angle, then it's acute. Now we could try to write it the other way. If it is an acute angle, then it is 30 degrees. Well, the first one, so I'll call this one here number 1. Number one is always true, because if the angle is 30 degrees, then it is acute. This first one's always true. The second one's not going to be always true. It's going to be sometimes true. Because if it's an acute angle, then it's 30 degrees. Well, what about, say, 45 degrees? 45 is still an acute angle, but it's not 30. So that one there is not always necessarily true. Just because it's an acute angle doesn't mean it's 30 degrees. But if it is 30 degrees, then it's acute, is an acute angle. I should really add angle in there. Acute angle. So that does work. So the first one works all the time because 30-degree angle will always be an acute angle, but an acute angle will not always be 30 degrees. So it works sometimes one way. Now it can work sometimes both ways, and we'll cover those tomorrow. But here, this one only really works one way. So we want to identify our hypothesis and our conclusion. So the hypothesis, so we have 2x plus 7 equals 1 because x is equal to negative 3. So because this here is really identifying our conclusion, because, so if this, then that. This starts, then this proves it. Because of this, because this is our reasoning, because it's kind of a reasoning statement, so it's our conclusion. Because is a way to identify the conclusion. So because gives us the conclusion, which means 2x plus 7 equals 1 is our hypothesis. So what we can say with that is if 2x plus 7 equals 1, then x equals negative 3. And that's it. That's all we have to do for this in the if-then form. If 2x plus 7 equals 1, then x equals negative 3. And that's it. That's all we have to do for this here. X is less than 5 if x is greater than 3. So kind of our if, again, this set this off to telling us that this is our hypothesis, which means this here is our conclusion. So this one here is a little bit easier. If x is greater than 3, then x is greater than 5. Is this always true? Well, no. Not always true, because what if x is 4? If x is greater than 3, well, if 4 is greater than 3, then x is greater than 5. 4 is not greater than 5. But this is kind of how we set this one up. So this is our last one here of these kind of if-then, writing an if-then form and highlighting. So all members of the soccer team have practice today. So what if, so what are we talking about? If members of the soccer team, someone's on the soccer team, then what happens? They have practice today. So we might have to change the wording a little bit this. If you are on the soccer team, then what? Then you have practice. So if you're on the soccer team, then you have practice. So anything that comes after if is normally the hypothesis. Anything that comes after then is normally the conclusion. So if, hypothesis, then conclusion. And that's all we have for this part here. Now that brings us to the next thing, the negation. The negation, I find, is sometimes the most students' favorite part, because the negation of a statement is the opposite of the original statement. The negation of the statement P, you write this symbol, this little squiggle line before the letter. So not P is written as a little squiggle line, P. So if we say the ball is red, we're going to say the negation of this statement is the ball is not red. Now we won't say the ball is pink or the ball is purple or the ball is blue, because the negation is just the opposite. So the opposite of the ball is red is the ball is not red. Saying the ball is pink is not the negation, it's just another way of saying it. It's just different. The negation is the opposite. So we add not into it. So like the second one, the cat is not black. So the negation of that is going to say the cat is black. And that's all we have to do. We have to either add not or we have to remove it. So the first one, the ball is red. Well, the negation of the ball is red is the ball is not red. the cat is not black, well, the negation of that statement is the cat is black. And that's it. So this one here, if we say the car is white, well, the negation of it is the car is not white. And here, if it is not snowing, well, the negation of it is snowing. And that's all we have in negation. It's just the opposite. It is the opposite of the statement. So we'll do two more because they're not too bad. So this here, the shirt is not green. Because since it said the shirt is green, the negation of it is saying that the shirt is not green. The other statement, the shoes are not red, well, the negation of it is saying that the shoes are red. And that's all we have to do for these here. The negations are pretty easy. And that brings us to the last part, our related statements. So we have kind of four. We have the conditional statement, if, then Q, which we've done already. We have the converse, if Q, then P. So we flip it. We flip the hypothesis and conclusion. So we have the conditional statement, then we have the converse, which is the flip. So the converse is flip. We flip the if and the then. We flip the hypothesis and conclusion. We still have it as if then, but the conclusion comes first, the hypothesis comes second. Now what comes after that is the inverse. The inverse of a conditional statement negates both the hypothesis and conclusion. So we negate both. It's almost the same as our original statement, but they're the opposite. And the contrapositive flips the inverse. So we have our if then, and then we have our converse, which switches them. Inverse is the opposite, and then we switch it again. Now a conditional statement is equivalent, and it's contrapositive. So the conditional statement is contrapositive to be either both true or both false. Similarly, the converse and inverse of a statement are either both true or both false. In general, when two statements are both true or both false, they are called equivalent statements. So let's look at this here. So we're going to look at this if-then and writing these out. So most of these are going to be hopefully pretty understandable. So we have if P then implies Q. P implies Q. Well, our P statement is you're a guitar player. So if you are a guitar player, then, so Q statement is you are a musician. And this is our first statement. If you're a guitar player, then you are a musician. So that is our first conditional statement. If you're a guitar player, then you're a musician. Now, our second one, the converse, is flipping it. So we have if Q, well, our Q statement was you are a musician, then what? You are a guitar player. And that's it. That's all we have to say for that there, because we switched it. Now the next one is the negation, if not. So our negation of P, so P was you are a guitar player. So the opposite of the guitar, you are a guitar player, is you are not a guitar player. Then you are what? Not a musician, because again we negated them. We negated our original statement. So our P was originally you are a guitar player. So the negation of it, the opposite of it, is you are not a guitar player. Our conclusion was originally, our Q originally was you are a musician. So the negation of you are a musician is you are not a musician. So our inverse is if you are a musician, then if you're not a guitar player, then you're not a musician. And our last one, we switch it. If you are not a musician, then you are not a guitar player. And these are our four statements here. So our original one, if you're a guitar player, then you're a musician. If you're a musician, then you're a guitar player. If you're not a guitar player, then you're not a musician. And if you're not a musician, then you're not a guitar player. Now, what we're going to do next is we have either these statements are going to be true or they're going to be false. They're going to be one or the other. Now I'm going to color these bright red. Let's color these red. Okay, so what we're going to look at these here, these four statements, and we're going to determine whether they're true or false. So let's look at the first one. If you're a guitar player, then you're a musician. Well, guitar players are musicians, aren't they? So if you are a guitar player, then you are a musician. You play a musical instrument. I would say that this is a true statement. That is true. If you're a musician, then you're a guitar player. Well, are there more musicians than just guitar players? I mean, you could play the sax, or you could play the violin, or you could play the piano. You can play any number of musical instruments and still be considered a musician, even though you're not a guitar player. So it could be that you are a musician, which is true, but not a guitar player, which is false, which means the whole statement here is false. So this here is false. Just because you're a musician doesn't mean you're a guitar player. So we say false. If you're not a guitar player, then you're not a musician. Well, that's going to be false again. Because again, just because you're not a guitar player, you could be playing the saxophone. And just because you say play the saxophone means you're not a guitar player, but you are still a musician. So that is false. If you're not a musician, then you're not a guitar player. I would say that's true. Because again, if you're a guitar player, you are a musician. Well, if I'm not a musician, it ends up being a true statement, because if you're not a musician, then you're not a guitar player. Well, if I'm not a musician, I'm not going to play the guitar. It just doesn't work that way. And that's it. Now, one of the things they were saying earlier, it works out that the conditional statement and the contrapositive are going to have the same truth value, and the converse and inverse are going to have the same. So the converse and inverse will have the same truth value, so if one of them is false, the other should be false. The contrapositive and conditional statement should both have the same one. So if one of them is true, the other has to be true. Or if one of them is false, the other has to be false. So let's look at another example of this. So we say if P, then Q. So our P statement for this year is you are in New York City, then you're in the United States. If you're in New York City, and I abbreviated New York City to NYC, then you're in the United States. If you're in New York City, then you're in the United States. So that's our conditional statement. Now our converse, again, we switched the hypothesis and conclusion. So our conclusion was if you are in the United States, then what? Then you're in New York City. So that's our converse. We switched the hypothesis and conclusion. Now, the inverse, not P, implies not Q. Well, not P, so the inverse, or kind of the opposite of P, the negation of P. So you are in New York City. Well, the negation is you are not in New York City. So if you're not in New York City, then you're not in the United States. So we negate both of the statements. So if you're not in New York City, then you're not in the United States. And our last one is we flip it. So if you're not in the United States, then you're not in New York City. And we have these here. Now again, we're going to decide whether these are true or false. Decide to write each statement and decide whether they're true or false. So if you're in New York City, then you're in the United States. Well, yes, New York City is part of the United States, so this is true. And again, we only need one example for these to be false. So let's look at the next one. If you're in the United States, then you're in New York City. Well, how about Colcord, Oklahoma? Is Colcord, Oklahoma in the United States? Well, yes. So if I'm in Colcord, Oklahoma, where you all are watching this video, yes, I'm in the United States, but I'm not in New York City. So this here is false. If you're not in New York City, then you're not in the United States. Well, that kind of going along the same lines with the one before. Just because I'm in Colcord doesn't mean, since I'm in Colcord, it means I'm not in the New York City, but I'm still in the U.S. So that's false. Because Colcord is in the United States, but we're not in New York City. If you're not in the United States, then you're not in New York City. Well, yes. Because if I'm not in the U.S., I can't be in New York, because New York is in the United States. Because if I'm not in the U.S., I have to be somewhere else. And I can't be in New York. So we have these here. Now, it could work out that they all work out to be true statements. So it could be that all four of them are true, or it could be all four of them are false. We could have either one. So that's all we're going to cover with this here. If you have any questions, please email me, and I will get back with you on how to get them done. So at this point here, go on and go work on assignment 2.11 in Big Ideas Math.